This specification is prepared for the purpose of carrying out confirmatory/verification soil investigation work within the proposed plot at respective locations. Scope of the geotechnical investigation shall include ascertaining the existing conditions, subsoil strata, level of groundwater table, and determination of various engineering and chemical properties of subsurface soil by employing field as well as laboratory tests. It is required to propose a suitable foundation system for different types of structures based on techno-economic considerations. The need for soil investigation. Soil investigation is a vital step in any construction project. It's required to ensure the safety and stability of structures we build. Without proper investigation, we risk costly mistakes and potential disasters. Scope and purpose of geotechnical investigation. Geotechnical investigation is essential for our project located at your project location. The aim is to understand existing conditions, subsoil strata, groundwater levels, and soil properties. It helps us propose suitable foundation systems based on techno-economic considerations. This is critical for ensuring the structural stability of our upcoming project. The subsurface investigation shall be carried out generally in accordance with this specification. The soil investigation work shall be generally carried out as per the provisions of BS 5930, latest version. The adoption of any particular method and procedure of the soil investigation shall be dependent on this specification and in consultation with the EPC contractor. The extent of work shall be in accordance with Bill of Quantities. The depth of exploration shall be governed by Section 4.0 of this specification and shall be to the satisfaction of the EPC contractor. On completion of subsurface explorations, a detailed report of visual inspection of soil characteristics, the level of groundwater table, etc., along with results of laboratory and field tests and their analysis, giving salient geological features, shall be submitted to the EPC contractor. These details shall be clearly indicated with respect to each reference borehole. The contractor shall provide their foundation recommendations for open, pile foundation in the format as given at the end of this document. To provide information regarding the most suitable method for soil improvement wherever required. Subsurface investigation. The subsurface soil investigation is to be carried out to arrive at the topographical features and gather information about strata in the subsoil and groundwater conditions. The subsurface investigation work shall be carried out generally in accordance with BS 5930, latest version. Also, this investigation should help in arriving at different characteristics and nature of soil, the pre-consolidation it has undergone, and the information for carrying out any additional detailed investigations and method of explorations to arrive at soil foundation systems. Recommended locations of various field tests are indicated in your document. Boring. The boring shall be carried out in all types of deposits, including boulders or gravelly strata and excluding hard rock, by the applicable method with the specifications given below. Boring shall be carried out to proposed depths, below natural ground level, as given in the table of attachments -1 and 2 of this document. In order to confirm the existence of hard rock, a minimum depth of 1,000 mm shall be drilled in the hard rock stratum, if met with. When the rate of advancement of boring by chiseling is slow, i.e., less than 20 cm in 4 hours, the contractor shall advance core drilling with NX size double tube, triple tube core barrel of the approved design fitted with a diamond bit. Auger boring. Augers shall be of helical or post hole type and may be manually or power operated. The diameter of the hole shall be 150 mm. Uncased holes shall be permitted only up to a depth where the sides of the hole can stand unsupported. In case side fall is noticed, steps shall be taken immediately to stabilize the hole by using casing pipes. No water shall be added while boring through soft cohesive soils and cohesionless soils above the water table. While boring through cohesionless soils below the groundwater table, water in the casing shall always be maintained at or above the groundwater table. In stiff cohesive soil, it may be necessary to soak the borehole before any progress can be made. While boring, care shall be taken to minimize disturbance to the deposits below the bottom of the borehole. In situ tests shall be conducted, and undisturbed samples shall be obtained at specified depths from the borehole. The borehole shall be kept clean and free from foreign matters while conducting these operations. Water table in the borehole shall be carefully recorded and reported. One of the following methods shall be adopted for measuring the water table. Method A is suitable for permeable soil, while methods B and C are suitable for both permeable and impermeable soils. A. The water table in the borehole shall be allowed to stabilize after depressing the water level adequately by bailing. Stability of the borehole sides and bottom shall be ensured at all times. B. The borehole shall be filled with water and then bailed out to various depths. Observations shall be made at each depth to see if the water level is rising or falling. The depth at which neither a fall nor a rise is observed shall be considered as the water table depth. This shall be established by 3 successive readings of water levels taken at intervals of 2 hours. The established reading shall be verified after 24 hours. Slough method, Ref. Foundation design by W.C. Tang. The water level shall be depressed by bailing, to say D below ground level, and shall then be allowed to rise. Water rise at suitable equal intervals of time shall be recorded. If H1 and H2 are 2 successive rises of water level in the borehole for the same time interval T, then H0, the distance of the depressed water level from the actual water table, shall be obtained as under. H0 equals H12. H1, H2. The water table depth HD from ground level shall be determined as under. HD equals D, H0. 3 sets of observations shall be made, and the average value of HD determined immediately on completion of the borehole. Shell and auger boring. The requirements mentioned above in Clause 4.1.1 shall also apply to shell and auger borings. The auger shall be used for soft to stiff clays, the shell for very stiff and hard clay, and shells or sand pumps for sandy strata attached to sectional boring rods. The use of a chisel bit shall be permitted only in boulders and thin strata of rock. Mud rotary drilling. Mud rotary drilling with bentonite slurry shall be carried out as per the standard method. Care shall be exercised in thoroughly cleaning the hole prior to recovering undisturbed samples and carrying out in situ tests. Percussion boring. Percussion boring shall be carried out as per the methods suggested in BS 5930. This method of boring shall be adopted for drilling boreholes in boulderous and gravelly strata. Backfilling of boreholes. On completion of boreholes, backfilling shall be carried out with cement grout. In situ tests. The in situ tests shall be carried out generally in accordance with this specification and as per requirements given BS 5930. Standard penetration test. The procedure of the standard penetration test shall be as per BS 1377, Part 9, determination of penetration resistance using a split barrel sampler, SPT. These tests shall be conducted in all types of deposits and layers at intervals not exceeding 1.0 meters to a depth of 10 meters, and then at maximum intervals of 1.5 meters within a continuous stratum, or at every change of stratum, whichever is less. The test shall be performed on undisturbed soil by driving a 50 mm, 2-inch, diameter split spoon sampler by means of a 64 kilograms, 140 pounds, hammer with 76 centimeters, 30 inches, free fall. The number of blows required to drive/penetrate the first 15 centimeters, 6 inches, to allow for the presence of disturbed material. The number of blows to drive the sampler a further 30 centimeters, 12 inches, of penetration is then recorded as N values. The samples obtained in the split spoon sampler shall be labeled and preserved for identification tests in the laboratory. The test shall be terminated at an SPT value of greater than 60 or after reaching the minimum borehole depth, as defined in Clause 4.1 above, whichever occurs earlier, subject to refusal not occurring. For hard strata, when SPT is greater than 40, SPT shall be carried out at 1.5 meters interval. 4.2.2 Cone penetration test with piezo cone. This test shall be carried out by pushing an electrical cone assembly with pushing equipment having adequate capacity to reach the desired depth. 4.2.3 Vein shear test. In situ vein shear test shall be carried out as per the relevant BS standard to determine the shear strength of cohesive soils, especially soft and sensitive clays, which are very susceptible to sampling disturbance. This test shall be conducted by advancing a 4-winged vein of suitable size, 75 mm to 100 mm diameter as per soil condition, into the soil up to the desired depth and measuring the torque required to rotate the vein. On completion of the test, the results shall be reported in a standard format. 4.2.4 Load information, reference drawings. A. Loading information for various types of structures, giving estimated loads shall be as per attachment 3. B. For reference drawings, refer to attachments -1 and 2 as under. Attachment 1, plot plan showing locations of proposed boreholes and soil tests. Attachment 2, plot plan showing locations of proposed boreholes and soil tests. Soil samples. The soil sampling shall be carried out generally in accordance with this specification BS 5930, latest version. Various methods of soil sampling shall be adopted depending upon the nature of strata encountered. Borehole sampling. The samples shall be collected and preserved in accordance with BS 5930. Every sample shall be carefully labeled, and a sketch indicating the depth of the sample shall be maintained. In situ samples. Samples obtained from the in situ tests shall also be properly labeled. The samples shall be preserved in accordance with the relevant test standard and kept ready for transportation. Laboratory testing. Laboratory tests shall be conducted on the samples collected from the boreholes. The tests shall be conducted in accordance with IS 2720, latest version, and the relevant British standard as applicable. The standard of samples shall be generally as per BS 5930. Groundwater conditions. Groundwater conditions shall be established in all boreholes as far as possible. The contractor shall monitor the boreholes for possible water-bearing strata and note the depth from ground level, quality, potable or otherwise, and the salinity of water wherever it is encountered in the boreholes. If artesian conditions are encountered, the same shall be controlled by installing suitable strainers and casings. Testing for contaminated soil. Samples from the boreholes shall be tested for the presence of any contaminants. In the event of contamination being detected, steps shall be taken to locate the boundary and source of the contamination. Any such contaminated soil encountered shall be removed and disposed of in accordance with applicable laws and regulations. Testing for engineering properties of soil. Testing shall be carried out as per IS 2720, latest version, and the relevant British standard as applicable. Grain size distribution. The particle size distribution of soil samples shall be determined by sieve analysis and hydrometer analysis. The hydrometer analysis shall be done on fine-grained soils having a liquid limit less than 50%. From the sieve analysis and hydrometer analysis, the percentage of various sizes of particles in the soil shall be determined. Atterberg limits. Liquid limit and plastic limit shall be determined as per IS 2720, latest version. Specific gravity of soil particles. The specific gravity of soil particles shall be determined as per IS 2720 Part 3/Sec 1, latest version. Water content and density. The water content and density relationship shall be determined by compaction tests, either by standard Proctor or modified Proctor tests as per IS 2720 Part 7, latest version. California Bearing Ratio, CBR. CBR tests shall be conducted on representative soil samples at desired intervals as per IS 2720 Part 16, latest version. Unconfined compressive strength. Unconfined compressive strength tests shall be conducted on representative soil samples where applicable as per IS 2720, Part 10, latest version. Shear strength parameters. Shear strength parameters, i.e., C and Phi, shall be determined for cohesive soils as per IS 2720, Part 13, latest version. Consolidation test. Consolidation tests shall be conducted on representative soil samples as per IS 2720 Part 15, latest version. Permeability test. Permeability tests shall be conducted on representative soil samples as per IS 2720 Part 18, latest version. Preparation of borehole logs. General. Logs of all boreholes shall be prepared as per the format enclosed at the end of this document. Borehole logs. A boring log shall be maintained for every borehole. The boring log shall include the following details. A. Borehole number. B. Location of borehole with respect to the plot plan. C. Depth of borehole. D. Date of drilling. E. Type of boring. F. Details of strata encountered. G. Nature of soil and description. H. Water table details. I. Rock samples, if encountered. J. Boring advancement rate. K. Results of in situ tests. L. Results of laboratory tests. M. Observations and remarks of the contractor. Soil test logs. Soil test logs shall be prepared for each soil sample tested. The log shall include the following details. A. Sample number. B. Depth from which the sample was collected. C. Date of sampling. D. Details of the test conducted. E. Results of the test. F. Remarks of the contractor. Foundation recommendations. General. The contractor shall submit recommendations for suitable foundation systems for the structures based on the geotechnical investigation results and considering techno-economic factors. Specific recommendations. A. For isolated foundation for buildings, equipment supporting structures, pumps, columns, pipe rack, pump foundations, and minor foundations if any, the maximum permissible settlement shall be 25 mm with a maximum differential settlement of 10 mm. For pad foundation for tanks, the maximum permissible settlement shall be 40 mm with a maximum differential settlement of 20 mm. The maximum settlement at the center shall be 300 mm, and at the edge, it shall be 150 mm. For raft foundation for buildings, the maximum permissible settlement shall be 40 mm with a maximum differential settlement of 20 mm. The maximum settlement at the center shall be 300 mm, and at the edge, it shall be 150 mm. Foundation drawings shall be prepared in accordance with the standard engineering practices and submitted for approval. BS 1377, Part 9, 1990, Methods of Test for Soils for Civil Engineering Purposes. Determination of penetration resistance using a split barrel sampler, SPT. IS 2720, latest version, methods of test for soils. Foundation design by W.C. Tang, reference for Vorslew method. Other relevant British standards and codes of practice. If you need any further modifications or additions, please let me know. Thanks for watching.